We're Columbia University, team number 263, and this is our accumulator. So as you can see, we have the high voltage international standard triangle, as well as high voltage and always energized available on the top of our lid. So now I'll go over our high voltage path, starting from our negative terminal of the battery pack. So as you can see, everything on the disconnect bar has tab washers for positive locking, all the way until our positive terminal. This disconnect bar is also covered with a dovetail printed cover. So coming from our negative terminal, we flow through the service plug, go to our first airs. So our airs have nylock on them for positive locking. Every single connection on the high voltage path is bolted. There's no solder, and they're all positive locking. So continuing from the airs, we flow through the energy meter, which are both safety wired as well. And the path continues on into the negative terminal of the inverter, going through our current transducer for the BSPD, as well as the test wires to prove BSPD functionality. Now, coming out of the positive terminal, we flow through our high voltage fuse, through the second airs, which also has nylocks. The high voltage fuse actually has safety wired bolts, set screws. And after the airs, we flow through our high voltage disconnect, also has safety wires. And then through this basically junction, we'll talk about the branch circuits in a minute, and then into the positive terminal of our inverter. I will also note that the three-phase connector, which connects to our inverter, also has safety wired bolts on the connector. So both terminals of our battery pack lead into this little compartment in our accumulator with all of its walls covered in Nomex paper to insulate it from the container itself, as well as capped on tape to seal the Nomex paper. Our airs and our high voltage fuse, which has been approved on our ESF, is also covered with this 3D printed flame resistant high voltage insulating ABS. Additionally, the always live terminals of our battery packs is always contained inside this container. High voltage never leaves the accumulator unless the airs are closed. So now I will demonstrate that all of our branch circuits are under 150 millimeters using this string. So coming into this section, our battery plus branch circuit for the pre-charge goes from the airs cover into the airs terminal to the base PCB, which, as you can see, the string is much longer than the wire attached. Then our inverter plus branch circuit, which goes from this bolt to that base PCB. Again, as you can see, our string is much longer than the wire itself. And finally, the tap from inverter minus for our pre-charge circuitry goes from this bolt into that same Molex pin over there. And as you can see, our string is much longer than that wire. So on the inside of our accumulator, we're going to go over LV, HV separation. So first we'll start off with our base PCB, which is this black PCB that you see in the main area. So the right side, my right side, your left side, is low voltage. The other side is high voltage. And we got 12.7 millimeters of separation in between, except for one caveat, which I'll go over in a second. We also have this team designed and built tractor system active light and accumulator indicator light controlling board that has a separation of 5.79 millimeters. However, it is conformally coded to meet all rules restrictions. We also have the insulation monitoring device board, which was purchased and also conformally coded. All right, so coming back to our base PCB, for a majority of the separation, we have 12.7 millimeters as marked on the board, except for this one area here where a component trespasses between both sections. We have only a 10.94 millimeter separation, and to make up for that, we have an air gap that makes this separation rules compliant. In addition to those PCBs, we also have our team-designed battery management system boards. And these boards are also have a small gap of 4.5 millimeter separation here, which has been compensated for with conformal coating. The conformal coating that we use is this right here. I will now demonstrate our maintenance plugs disconnecting. So without the use of any tools, our cells slide out, disconnecting our maintenance plugs, which are these black methode connectors. They're made of plastic, non-insulating material. The only possible electrical conduction is through these high voltage terminals there. Our maintenance plugs cannot be installed in the wrong orientation, as the blue LV blind mate connectors prevent that from happening. They can only slide in this direction. The casings for these battery stacks are made of FR4 high voltage insulating material. And as mentioned, the maintenance plugs can only be plugged in this orientation. So now I'll demonstrate the functionality of our high voltage indicator light as well as the interlocks in our high voltage connectors. So first I'll turn the car on, GLV turns on, we got the green light, we reset the shutdown circuit, and then we switch the TSMS, that activates the red light, and we pre-charge successfully from the multimeter. Second airs flips, we get our full battery pack voltage at our TSMPs. Now first I'm going to disconnect the TSMP connector, and that should open the shutdown circuit as you heard. We come back to the green GLV state. I flip the TSMS switch, pushing that connector back in. Switch that TSMS again for pre-charge. As you can see, we pre-charge successfully. And then once the second airs clicks, we're ready. And now I'll demonstrate our high voltage disconnect interlock. So first, we have to remove that. And as soon as that comes out, as you can see, we're back to the green light GLV state. In the meantime, I want to show you the interlocks in between the high voltage, high current contacts. We got these tiny interlock connections there. So turning off the TSMS, putting back our high HVD, flipping TSMS again, pre-charging one more time. Yep, there's the second airs. Now I'll remove the charger dummy connector. So that, as you can see, I'll show this type of connector as well. The interlocks are in the middle over there. So once again, turning TSMS, putting the charger back, flipping TSMS one more time, pre-charging once again, the red light blinking. And now I'll show our three-phase connector as the final high voltage interlock. And yeah, we discharge back down to a few volts in under 5 seconds. This is our charging box. Essentially, we'll be connecting to our accumulator using this orange connector, which has interlocks in the middle. Also, our charging box comes equipped with master switches, shutdown button, as well as a TS plus and a TS minus, a banana jack, and a GLV measuring point as well.